Alright guys, welcome to my next video. For this cycle, I created a project called Smallprox. The goal of this project was to create a small proxy program. I wanted to make it as small as possible. However, I did want to do the full RFC for the SOX protocol, and that seemed untenable for a 2-week cycle, so I decided to just make it as small as possible. I did add, there are two features I thought that would be pretty cool. One is that it compiles in both Windows and Linux, and the second is that direction decisions for the proxy are compile time based, not runtime based. And what I mean by that is when you compile Smallprox, you make the decision of what port and IP address the proxy will interact with then and there, not when you attempt to run it on either your host or a target host. So let's go ahead and look at the project. To look at the project, we're going to pull it up in Visual Studio. So here we can actually see the code. I'll walk through just a little bit of the code to show you guys kind of what's going on, but I won't focus too much on it. You'll notice in the code that there are a lot of pound defines or compiler preprocessors. This is to differentiate between Windows and Linux networking code. By default, if you compile it with no compile time options, the proxy will proxy between 127.0.0.1 on port 1234 to 127.0.0.1 on port 8080. And that's what I'll be using for a part of the demo as well. Once you get into here, it's a lot of networking code. A lot of stuff is just template that you need to set up. It does not currently support domain names. It does need to be IP addresses. Domain names could be something to be added later on. That might make it helpful. Otherwise, we're setting up two sockets. We're going to listen on one and send on the other. We're going to accept data from our client. We're then going to copy it directly to the socket that's sending out to our destination, because that is, in essence, how a proxy works. You'll notice I'm not actually speaking to any specific part of this code. Feel free to go through it and check it out. The other thing you'll see here are these pound defines for debug. It does support a debug versus release mode, or really just not debug mode. And that will print out more information if you're trying to figure out what's going wrong or what's happening. The release mode does not include any printing statements, whereas the debug includes all of the printing statements. So, like I said, it's just a lot of Windows and Linux networking code. Lots of it can overlap. One of the big differences for Windows and Linux is the WSA subsystem, for lack of a better term. You have the Windows socket code that essentially needs to start and clean up before sockets will work on Windows. Otherwise, there's specific functions that need to be called for Windows or for Linux, and there are some functions that are supported on Linux and not on Windows, for example. A lot of that functionality wasn't added in this first release, but it does compile cleanly on both. So let's go ahead and do that. Since we have Visual Studio open, we're going to compile debug and release for 32 and 64-bit versions all in one. We'll go to build, we're going to batch build. We've got all of them selected here, and if we hit build, it will start building all of them for us. And there at the bottom we can see build 4 succeeded, 0 failed, 0 up to date, 0 skipped. So it built all of our code that we needed. We can actually check that out too. In the debug and release, those are going to be our 32-bit versions. We can see the Smallprox debug executable there, and we can see the Smallprox release executable there. I also would like to point out the compiled sizes. The release size is significantly smaller than the debug size for Windows, and that is one of the things we were looking for, is a small option. And likewise, we can see the 64-bit versions. Release and debug. So now that we have these, I'm also going to compile it for Linux. So I'm going to go ahead and use the Windows terminal here to open up a Windows subsystem for Linux terminal. I prefer Ubuntu. And then in here we're going to use GCC. So GCC -O for output. I'm going to do Smallprox, and then it's going to be debugger release and the architecture. So we'll start with debug 64. The file we're actually compiling is just main.c. There is no other code. Everything you need is in the main.c file. The one thing that Visual Studio did behind the scenes that we didn't really see or talk about is the debug compile flag. So when using GCC, we need to explicitly pass in the debug compile flag, and we do that by doing -D and then immediately whatever that flag is. So in this case, it's going to be _debug. That will enable the debug flag so we can get the error messages printed out to the screen. And to make it cleaner, we're going to turn off an error. No incompatible pointer types. And this will just make the output cleaner when we compile it. So we can see that worked. Let's go ahead and do the non-debug version for 64. Cool. And now I have this installed already, but you will need to install GCC multi-arch or multilib to get compilation for 32-bit. But since I already have that installed, I'm going to go ahead and do that. Once you have it installed, it's as simple as just m-m32. Remember, when you're doing debug, _debug. Here we can see there is a warning because one of the format strings in debug is %LD, which is a long. That is going to be different than the size when in 32-bit. That can be corrected either with a preprocessor declaration or probably just better coding on my part. But it's not an error, it's just a warning. And then we'll do the release for 32-bit. We leave the M32, but we get rid of the debug flag, and we will call it release. There we go. So now we can see all of our compiled binaries for Linux as well. Again, all the same code. The compiler and preprocessor and all those declarations take care of which code gets compiled when, or for which architecture and which operating system. So you don't need to worry about that. Now to actually run it, I'm going to do the defaults since I didn't pass in any of the compiler time directives to change the IP address or ports. It's going to proxy from 127.0.0.1 on port 1234 to 127.0.0.1 on 8080. So let's go ahead and set up an example here. We're going to split our window. So this is going to be our server. This is a web server that Python has, and we're going to bind on the localhost interface on 8080 and let that just run. And then here, we're going to pick any one of them. It doesn't really matter which one we pick. So the Smallprox is now running. So let's open up a browser. And we'll go to 127.0.0.1.1234. Remember, that's the proxy address, and it's going to proxy our traffic to 127 on 8080. And there we can see it proxied our traffic. We browsed to port 1234, but the program grabbed all our data, sent it to the correct location, retrieved all our data, and sent it back to us. hopefully this is a sufficient demo for you guys. There are more commands and examples on the GitHub page for switching up IP addresses and ports. Hope you enjoyed. Talk to you again later.